The moon declares God's glory by its tremendous beauty and the fact it does exactly what God designed it to do.
I think the moon does things for us we haven't even explored yet.
And there are a lot of design aspects in the moon. It's not just a body that's orbiting on the Earth, it's actually doing something.
God provided all these objects with a magnetic field as a clue to how He created those objects and how long ago He created those objects.
The cratering rates are much different than what the secular model says, and that collapses the ages of a lot of objects throughout the solar system.
If you can't explain the moon, which natural science can't, then you can't explain anything.
Its properties are so difficult to explain naturally that I have to believe in a supernatural origin.
And the natural response to that is to worship the God who created it.
In the night sky, we are often in awe of a glowing orb which circles the earth. We're told in Genesis 1, God made the moon the same day He made the sun. He called it the lesser light to guide the night. But it was designed for more than just providing light. It controls many processes we are just beginning to understand.
The moon declares God's glory by its tremendous beauty and the fact it does exactly what God designed it to do. It's the one that tells us months and what part of the month that we're in by its cycles.
You know, some critics will say, well, we don't need that moonlight. That's kind of a funny design argument. But for most of history, of course, that moonlight has been very valuable to explorers. Sometimes I think that the moonlight, still today in agriculture and farming, does more than we really understand as far as the growth, propagation of seeds. I think the moon does things for us we haven't even explored yet.
If you've ever seen the moon through a small telescope, and it doesn't take a big telescope, I'm talking even a cheap telescope, you look at the moon with it, it is stunningly beautiful. One of the astronauts that walked on its surface called it a magnificent desolation, and I think that's a wonderful description of the moon. It's not designed for life like the Earth is. It doesn't have beautiful valleys and rivers, but the cratered surface of the moon through a telescope is stunning, and it looks so three-dimensional, especially if you look at it in the first quarter phase when it's illuminated right down the middle there. It looks so three-dimensional. You can see the spherical nature of it, and you can see the shadows of the mountains and the craters, and the natural response to that is to worship the God who created it.
Astronomers study the origins of the universe. Some believe everything came about by chance and random processes, but they have presented only a few ideas on the moon's origin. Other astronomers believe in the Bible when it says that God spoke the moon into existence on day 4. What does the evidence really show?
Well, lots of time has been spent studying the moon, our nearest neighbor, figuring out how it got to be there. As the years have gone by, theories have come and gone on explaining the moon. Some centuries ago, the popular one was called the fission theory. In fact, one of Charles Darwin's sons, George Darwin, came up with this expression. He was an astronomer, and he said that long ago the Earth was spinning much more rapidly than today.
The moon spun away from the Earth after the Earth attained sufficient velocity, but if the Earth had such a velocity, it would never have formed in the first place. So that's a problem with that one.
In fact, it was thoroughly shot down actually in 1969 when astronauts first walked on the moon, and they brought samples of the moon back to the Earth. And as we've studied those, moon rocks don't look like Earth rocks. I mean, nothing new and exotic there, but the ratios of the isotopes are different, the types of atoms. It doesn't look like the moon came from here, after all. You have the capture theory, that the moon came from somewhere else. And one day it wandered through this part of the solar system and we reached out and grabbed it and captured it. That was a popular idea in decades gone by.
Well, that doesn't really solve the problem. It just says, oh, the moon formed someplace else. Oh, that's a good idea. Well, have you answered the question? I don't think so.
The capture theory is not really an origin theory. It brings in the moon from somewhere else, and we'll give them that, but it still doesn't work because the moon would escape, again, unless you can somehow decelerate it into orbit.
But it turns out that's very difficult to accomplish in space, a capture of that sort. You need a third body to absorb some of that energy. In addition, that doesn't explain the similarities between the Earth and the moon. I mean, it does have differences, but it also has similarities.
But when you do the physics of it, after a single pass, the moon would feel the Earth's gravity, and it would make like a half a turn around the Earth, but then it would escape. Like crack the whip, it would speed out of here. To capture the moon and keep it going around the Earth, you need to slow down the moon, insert it into orbit, put on the brakes, and how do you do that with a naturalistic theory? So that kind of went away. As the decades go by, I'm up to probably the 1980s or 90s, and the popular idea was called the nebula theory, that the moon just formed from a cloud of gas and dust. The moon and Earth were side by side, and these clouds collapsed and just became neighboring solid objects. You know, there are a lot of nebula still in space, and we look at those with our telescopes, and almost every one is expanding because gases and dust like to expand until they get small in the first place. So how do they get down to that size where they would stay small? It appears that we wouldn't have either Earth or a moon with the nebula theory. We just have a spray of gas.
You could say that they co-accreted, that they both sort of formed in about the same area, but that really doesn't explain the difference in composition between the Earth and the moon. You'd expect them to be made out of the same material if they formed at the same place in the same way.
And those seem to eliminate all the possibilities. Well, in the Apollo program, and about that time, with the samples they brought back and other things they learned, we were able to eliminate all three of those models. None of them work.
I don't think hardly anybody believes any of those three anymore, but they were very popular back when the moon program was going on.
One WAG suggested the best solution is the moon doesn't exist. In recent years, people come up with hybrid models where the Earth had a glancing blow from a Mars-sized object pretty early on and material splayed out.
And actually fragmented the Earth into pieces. And some of these fragments moved into space and coalesced together to make the moon. And the remaining parts of the Earth kind of fell back together. The details aren't worked out on this, by the way. But the idea that this formed the moon, it was a major collision.
They run computer simulations to show how this might have happened. But you know, a computer simulation is not the same thing as evidence. There's absolutely no evidence for this scenario.
Nobody's been able to work out the math to where it would really actually rigorously work out, where you get something like the moon. The impact has to be just right, and even then they can't get the masses to work out just right.
And I'm sure waiting in the wings is the next theory, because none of them work. And it makes a person want to just patiently speak up after a while and say, maybe these natural origin theories aren't the way to go. Maybe it's beyond explanation. Furthermore, if you can't explain the moon, which natural science can't, then you can't explain anything, because that's our nearest neighbor. I'm not sure that we have any right to try to explain the planets or the solar system or the galaxies of the universe beyond when we haven't gotten to first base explaining where our moon comes from.
And when I consider the unique properties of the moon, I'm convinced that its properties are so difficult to explain naturally that I have to believe in a supernatural origin. The moon's orbit is so different from the other planets and their satellites that it does bespeak of some sort of special status, either an origin or a purpose.
As far as science is concerned, it's perfectly consistent with the biblical teaching that God created the heavens and the earth, including the greater light and the lesser light, the sun and the moon.
And that's a refreshing aspect, I think, the creation viewpoint, to say the moon is not there by chance. In fact, there's reasons and purposes for the moon, and I think that's a neat way to look at this whole universe. It's a witness to the creation.
One of the fascinating features of the moon is all of its craters. Some craters are very small and a few very large. The origin of the age of the craters is a bit of a mystery to astronomers.
the craters of the moon. Right up to the 1950s, there were some questions of how they got to be there, whether maybe it's gases kind of erupting from inside the moon and then causing sinkholes or depressions. Today we know that that would be very rare. It might happen, but they're more likely caused from collisions, space collisions. There's a lot of debris in space, probably going back to the creation. And when these things hit the moon, they make a crater. The same thing hits the Earth, but they get erased because of the kind of weather patterns we have. The moon does have craters within craters, uncounted ones, and they've been accumulating ever since creation. I guess I would suggest that at the beginning there was more debris in space, and probably less today as it settles into the moon and other places.
You can have craters on the moon that are 70 miles across easily. Some of them can get very big. Some of the larger ones you can see, even naked eye, you can barely see Tycho, and it's easy with binoculars. That large white one near the bottom, Tycho, it has the ejecta, the white stuff that comes out from it. So some of them can get pretty big.
In current views of geology for the moon, it's very old, 4.5 billion years, and the craters all formed a long time ago, and that this is a very quiet period.
But actually it doesn't work, because at today's rates it would take even more than billions of years. You see, the rates haven't been constant. And what's interesting is even the secularists don't believe the rates have been constant. They also believe that the cratering rate was much greater in the past. So it's just a question of how much greater. Do we take their numbers or do we take our numbers?
At some point in history, maybe the moon really got zapped with a lot of craters. Maybe it goes right back to the creation week, or at some other point in history. We don't know.
In addition to the moon's craters, there are vast areas covered by lava flows called maria. The maria gives us some clues about the moon's age.
On the moon's surface, we see large, dark areas called maria. These are really interesting for several reasons. First of all, they give the moon its distinctive appearance that we see from Earth. Now, these are understood to be areas where something large has hit the moon and actually cracked the crust enough to where lava and other material can ooze up from inside and fill in the basin. So how long would it take for these basins to fill up with lava after these impacts occurred? You might think a few days, a few weeks, maybe a few months. The secular model says it took 500 million years. Why does it say that? Because in some places in the maria we see what are called ghost craters, which are partially filled in craters in the maria. Now, these are apparently craters that formed after the impact basins were blasted out, and then subsequent impacts occurred, and then the lava came and filled things in. Now, the secular model has certain requirements for cratering rates throughout the solar system at certain times. And if you take that rate and apply it to the amount of craters we see, it would have taken 500 million years to accumulate this many craters. Now that doesn't make sense though. Why would the moon wait 500 million years after these impacts for the lava to come out? I think it makes a lot more sense to acknowledge, well no, after the impact, the lava came out fairly quickly. That means though the cratering rates are much different than what the secular model says, and that collapses the ages of a lot of objects throughout the solar system, because cratering rates are one of the long age indicators that secular astronomers use to say that things are billions of years old. Recently, NASA just completed a 2.5-year study where they were observing impacts on the moon. And in the 2.5 years, on the near side of the moon, the side we can see, they observed about 103 impacts of various sizes. Now, when you extrapolate that out, that means that over the last 3 billion years since the maria were formed, the near side of the moon has been subject to 123 billion impacts. Now, each impact that they measured was, on average, they said, about a few hundred pounds of TNT. Now, when you work out the math on this, every acre on the moon's surface would have been hit by about 26 of these impacts in the last 3 billion years. Is that what the moon's surface looks like? Well, some places on the moon are very heavily cratered, but the maria, they have a few craters here and there, but they're not carpet bombed, which is what they would be over 3 billion years of this activity going on. To me, I see smooth maria, I see a moon surface that looks very young, not 3 billion years old in the case of the maria.
There was a time when scientists thought the amount of dust on the moon could tell us something about its age. But as it turns out, it's not quite that easy.
Well, the idea of the dust on the moon goes back some decades and was used as an argument for a young moon recently created.
The idea being the moon has been orbiting for billions of years and there is dust in the solar system, a small amount of it. It should act like a vacuum cleaner and collect that dust after a while. And there were some estimates that would say, well, hundreds of feet of dust should be on the moon. Well, and there's not. There's only an inch or so in terms of actual cosmic dust.
In fact, when the Apollo project happened back in the 60s and 70s, when we first went to the moon, there was some concern that there might be thick layers of dust on the moon that had accumulated over a long time span and a lunar lander could be swallowed up. Now, before we ever went to the moon with astronauts, we did land there with surveyor spacecraft. When they crashed there, we could see that there's not deep dust, but there was thought that there could be still some pockets of it. The whole idea that in deep time, lots of dust could settle on the moon. Of course, there wasn't. There were 2 or 3 inches of dust and it left some footprints, but that was about it.
And some creationists jumped on this and said, yeah, that's interesting. In a few thousand years, you wouldn't have accumulated that much dust, and so the moon looks young, and of course we know the moon is young. It's not a problem. So people started using that as an argument for a young moon. And what we would say now, though, is that probably shouldn't be used as an argument for a young moon. And the reason is we don't actually know the rate at which dust accumulates on the moon. That had been estimated based on the rate at which dust accumulates on Earth. We think those rates might have been contaminated by things like volcanoes and things of that nature, nickel from volcanoes and so on.
It turns out that to measure the amount of dust falling either on the moon or on the Earth from space, it's a difficult problem. We've tried to fly satellites and high-altitude aircraft, and we'll put sticky tape on them to try to collect dust, and we can try that, but the motion of those kind of things stirs up the dust. So we don't have a good count on how much dust there is out there that would be settling on the moon.
And if you don't know the rate, you can't make an estimation of the age. So dust on the moon does not argue either for an old moon or a young moon because we don't know what the rate is. At some point in the future, we might measure that rate and it might become a good argument again, but for right now, we recommend that people don't use that as an argument for a young moon.
When astronauts came back from the moon, they brought moon rocks for scientific study. Geologists hope it would give us some clues about the age of the moon through radiometric dating. But unfortunately, dating rocks isn't so easy.
Radiometric dating has been done on moon rocks. In fact, what a lot of people don't realize is it's rocks from outer space, things like moon rocks and meteorites, that they base the age of the Earth on. Yes, I mean, it really shows you how their philosophy has influenced their point of view. They would say, well, we know that the Earth rocks have been recycled, so on. So they use rocks from space to date the Earth. Interesting. Moon rocks date similar to meteorites and things like that, in that they give allegedly old age estimates of 4.5 billion years, something like that. That's because all those dating methods are based on certain assumptions, like the initial ratio of the elements and that there's been no contamination and that the decay rates have always been the same. And we now think that that third assumption is false. There's very good evidence that the rate at which radioactive decay happens can be accelerated, and we think it has been accelerated at one or more points in history. And if you don't compensate for that, your ages will be vastly inflated. But we do find good evidence of that inflation. For example, the fact we can carbon date anything, and whatever you carbon date, if it's got sufficient carbon in it, it'll give thousands of years. People think carbon dating gives billions of years. It never does. It's consistent with thousands of years.
For many years, rumors have spread that the moon landing was faked. The supposed evidence can look pretty convincing, but real-life testimonies, observations, and scientific data demonstrate otherwise.
Sometimes people will come up to me and say, did we really land on the moon? Wasn't that all faked on a sound stage because they saw some special on Fox or whatever? Well, yeah, we really did go to the moon. And in fact, I've worked with people who've worked with actual dust that was brought back from the moon. And I've seen moon rocks that have been brought back from the moon. So we definitely went there.
In fact, I was traveling 2 years ago in South Africa. A man came up to me, Christian fella, and He wanted to know, you don't believe they landed on the moon, do you? And I said, yeah. You don't? And he said, no. I said, give me a reason to believe. And I said, well, okay, you're a Christian, right? Yeah. All right, do you realize that 2 of the 12 men who walked on the moon, Jim Irwin and Charlie Duke, were born-again men? They're Christian brothers. He didn't know that. And I said to him, well, you know, when you say that we've never walked on the moon, you're accusing these 2 Christian brothers of the biggest thing that happened in their lives is a total hoax. They're liars and frauds. Now, are you really prepared to say that about a Christian brother? And I said, never thought of that. One is now deceased, but the other one, Charlie Duke, is still quite well alive. I saw him about a year ago. So he's the person you could ask, and he would assure you, yes, I really did walk on the moon.
It's interesting too because we didn't really have the technology in the 1960s to fake it. If you take a look at movies today, we're just now getting to the point where they can make it look real. Back in the 1960s, they couldn't do that. It was technologically possible to go. It wasn't technologically possible to fake it, which I think is very interesting. Also, we should know that they've put equipment there, including a reflector, and people can bounce a laser off the moon, off that reflector, and get the return signal, and it's there. Recently, we actually have spacecraft orbiting the moon, taking high-resolution pictures of the surface. We can actually see the lower portion of the spacecraft, because if you recall, they left the legs of the lander when they took off to save fuel. We can actually see those on the moon. All of the Apollo landing sites, they're there. And you can even see the trails of the footprints of the astronauts as they went out to investigate the various craters and so on. We have actual pictures of these today. I think it's a shame that people question that, because in a way it's kind of like, that was our finest hour right there. That was science at its best. Wow.
More than just a light source at night, the moon plays a pivotal role in the health of our oceans. The distance, size, and mass of the moon are exactly right for our tides and seasons.
The moon is about 1/4 the size of the Earth. It's about 80 times less massive, because that involves volume. We far outweigh the moon, although I must say our moon is, compared to the size of our planet, it's larger than any other moon when you compare the over 100 of them we have in the solar system. So I think we're given just the moon that we need. And all I can say is, with the distance that the moon has and with the mass that God's given it, it causes us the kind of tides that keep the ocean healthy.
If you had nothing blocking those tides, they could get fairly strong, but you have the tides running into the continents in between the oceans. The Earth itself gets pulled by the moon, and we don't feel it, but it gets pulled up about 1 foot. Those are called earth tides.
If you bring the moon closer to the Earth, then tides will increase. Tides are friction that causes heat. If you bring the moon close to us, the oceans could warm up. They could come to a boil. They could go away. And if you go the other direction, then the tides would be diminished. Then the ocean would settle down and become stagnant, and the life in the ocean could perish. Our life depends on the health of the ocean as well. And as we have found, there's a delicate balance here. It's even called the anthropic principle, that everywhere we look, it seems that things have been set up for our survival. And if you try to change these numbers for the moon, all of a sudden it becomes a danger to life on the Earth.
A little known fact is that our moon is slowly moving away from the Earth. It's not by much, but if you move back or forward in time, this lunar recession has big impacts on what we think about the age of the Earth.
As we study our moon, we have come to realize that the moon is moving away from the Earth. It's spiraling outward every orbit. Not that we see the moon getting smaller in the sky. It's only a few inches per year, so during a lifetime, no difference at all. But this adds up over 10 years, or 100 years, or 1,000 years.
This was first discovered in the late 19th century by George Darwin. He was the son of Charles Darwin. He was an astronomer, wrote a definitive work on the tides. Many libraries still have copies, still used. I've consulted it a few times. The thing is, there's a complex interaction going on. It's called the tidal interaction. I won't really go into the physics too much, but the moon raises tides in the Earth rapidly rotates, and that tidal bulge pulls the moon forward in its orbit like this, which is an acceleration. which over time causes the moon to slowly spiral outward like this, getting farther and farther away. It's only moving 1.5 inches or 2 inches, something like this each, like 4 centimeters. It's not much. And over my lifetime, it's moved my height a few times, maybe. It's not much, but when you extrapolate over a long period of time, it gets huge. We can model this somewhat well. It's a very steep function of the distance. It goes as the tidal interaction accelerating the moon goes as the inverse 6th power of the distance, which means that in the past, when the moon was closer, the interaction was horrendously high. So it looks kind of linear for a while, but then it departs radically from that. And I've run the numbers myself a few times.
When you do this math at the current rates that it's moving away and the equations of tide coupling as we know them, you come up with the conclusion that if you extrapolate back in time, the moon would be in contact with the Earth. It'd be right up against the Earth on a time scale of about 1.4 billion years. Now, I want to be careful. I'm not saying that the moon is that old. I'm saying that it can't be anywhere near that old. And yet, evolutionists tell us that the moon is 4.5 billion years old. It can't be. If you get the moon anywhere near the Earth in our vicinity, then the tide coupling would disintegrate the moon. It would pull it apart. We would have a ring around the Earth.
Now, if you have a choice between a 6,000-year-old creation and a 4.5 billion-year-old creation, and you've got this other argument that says that it can't be any more than 1.3 billion, it would seem to eliminate this one entirely. And this then leaves something less than 1.3 billion. The only one on the table right now is the 6,000 year. The point I'm making is that this is a very stiff upper limit to any theory of how old the moon is. Not a problem for us, big problem for the evolutionists. This problem's been recognized for a very long time, at least since the 1960s, probably earlier. And over the years, they've tried to suggest all sorts of solutions for this.
The lunar recession issue is interesting because this is one of the claims that creationists are making that the atheists say show that we're all washed up. They say that creationists have oversimplified this issue because if you look at other evidences, they will tell you that today's recession rate is anomalously high and that in the past it doesn't match a straightforward mathematical analysis of this. And they would point to things like tidal rhythmites, which are systematic layers of sediment in various places that are believed to reflect tidal patterns. And from the tidal patterns, you can then calculate the moon's orbit and so on. They would say that if you arrange the Earth's continents differently in the past, that tidal friction is less and therefore the recession rate would be less and so on. There's 3 or 4 reasons they give to try to support their claim. It turns out all of their claims themselves are not supported. Tidal rhythmites are very vague. Even among secular people, there's a lot of contention about whether or not, how much information you can glean from these things at all. They make big assumptions about what the Earth used to be like in the past, which I don't think are correct. And as far as rearranging the continents, there's an issue with that too. That makes the assumption that tidal friction is primarily occurring in continental shelves and shallow seas, which everybody thought was the case until recently. Some oceanographers discovered that a large portion of tidal friction occurs in the deep ocean bottoms. And deep ocean bottoms are going to be there regardless of how you arrange the continents. So if the atheists want to rebut the creationist argument about lunar recession, they need to go do their homework more than they have.
I had a discussion with some Christian astronomers a couple of years ago, and I asked for the evidence of this, and they give me the data, and they said, well, we got these computer simulations. And I said, that's not data, that's just a computer simulation. There is no evidence for this. It's just my Christian brethren and the evolutionists who believe in billions of years think that that solves the problem. But all they've done is they've given me a plausibility argument as to how you can get around this. It's what's called a rescuing device to make this work. And I think this idea of tidal evolution of the Earth-Moon system is pretty solid stuff. Also slows the Earth's rotation down. We documented that from eclipse data. And also since the last 40-something years with the reflectors on the surface of the moon, we actually can measure that directly. That's where we get the 4 centimeters. That's amazing. Something's 250,000 miles away and you can measure its distance to a fraction of an inch. That just blows me away that that can be done.
So the moon gives us clues that the universe may not be so old. To make the idea of naturalism even more impossible is a scientific principle called the ROCHE limit.
The ROCHE limit is the limit at which the force of gravity between 2 points in an orbiting object is insufficient to keep the object bound together. You can have moons inside the Roche limit a little bit, but they're held together chemically. Their gravity would not hold them together, which means a moon cannot form inside the Roche limit. It's impossible.
And if a planet's moon moves inside that Roche limit, then the gravity forces they can destroy the moon. They're stronger than the forces that are holding the moon together. So it's sort of a disintegration limit. The rings of Saturn are inside the Roche limit for Saturn, so you couldn't have a moon there. In fact, maybe those rings were a moon to begin with, but they've been pulled apart to pieces. So our own moon has to stay beyond the Roche limit for the Earth, or we wouldn't have a moon anymore. For the Earth, that's about 2.5 times the Earth radius, so the moon is well beyond that. But again, if you go back to this idea that the moon is slowly leaving the Earth, if you extrapolate back in time, then sooner or later you bring the moon inside the Roche limit, and the moon is pulled apart, it's destroyed. Now I want to be careful. We have satellites, artificial satellites, and they're not that far. They're inside the Roche limit, and they're not pulled apart. But it's not just gravity that's holding satellites together, it's rivets, which is stronger than gravity. So the Roche limit involves gravity forces of larger objects.
The magnetic fields of stars and planets can give us clues about the age of the universe. Even the moon had a magnetic field at one time, but its disappearance is a mystery to secular astronomers.
We know it has gravity just because it has mass, and we know that it's susceptible to the Earth's gravity, so it orbits the Earth. And we know from the astronauts bringing back some rocks from the moon that the moon once had a strong magnetic field, about the same strength that Earth now has. And this has been a puzzle to the people who want the moon and all the solar system to be billions of years old, because they can't figure out how the moon could have once had a magnetic field and now not have one. It rotates too slowly for their theories to work, and the core in it is too small for their theories to work. But the creationist view of the magnetic field of the moon is that it was created with a strong magnetic field, but it died away quickly because the speed with which a field dies away depends on the size of the core. The smaller the core, the faster it'll fade away. So we think those rocks on the moon were magnetized while the field was still strong. But over the course of 6,000 years, the field faded away to essentially nothing. My own guess is that God provided all these objects with a magnetic field as a clue to how He created those objects and how long ago He created those objects. So they're a bit like God's signature on His handiwork.
Gravity is one of the most basic forces of the universe. The play on gravity between the moon and the Earth is something of a fascination to scientists. Perhaps it could reveal clues about gravity operating in other parts of the universe.
When the moon feels the Earth and vice versa, whether there's a time lag there, whether they're in instant contact, that they feel each other's gravity, or whether, again, there's something invisible in gravity that has to travel from the Earth to the moon at the speed of light or whatever. And we're not sure about that. If gravity's instant, then yes, the sun and the Earth feel each other's pull moment by moment, instantly. If there's a time delay there, if some part of the gravity force has to move between the Earth and the sun, well, it takes light 8 minutes to go that far, so then it would take the gravity pull to move that far. So the idea that the Earth is kind of responding to a gravity of the sun from 8 minutes ago, that's being worked on today in physics to find out whether these kind of things all are controlled by the speed of light or whether there is instant contact.
If the moon was very old, any sign of geologic life could be non-existent. Yet the moon still demonstrates activity in what we call transient lunar phenomena, or TLP.
The moon If it's actually multi-billions of years old, it's like a museum. Everything should be worn out, everything should be settled down, there should be no more changes, maybe an occasional crater, but that would be it. Mainly amateur observers have watched the moon since we've had telescopes since the 1600s. They report seeing interesting phenomena on the moon. Small fractures that open up and like lava coming out, or emissions of gases from the moon as if there's pressures underground, small eruptions, and it'll kind of change the appearance of the moon for a while. It'll look kind of blurry and these gases settle down. So these are transient phenomena. They only maybe last for minutes, and I'm sure most of these kind of things are missed completely since they're going on. But it kind of shows that the moon is not dead or dormant or just an unchanging museum, but there's still some dynamics there. There are still some things happening. There are lunar tides, and that kind of distorts the moon and maybe releases some underground gases or magma turning into lava, things like that. So it's sort of a contradiction for evolutionists to see this, that is the deep time effect. But we would almost predict this, that the moon is not all that old, and so there are some of these transient temporary effects still going on to this day.
There are times in history when the moon has played a more prominent role, especially during solar eclipses. The fact that we have solar eclipses is remarkable, especially when you consider the odds of everything being just right.
The sun is 400 times larger than the moon, but it's also 400 times farther away. So in the sky, they both have about the same size, about ½ a degree. The moon just barely covers the sun up, making for very rare and very spectacular total solar eclipses. And no other satellite in the solar system does that. And it's the only place where there are creatures to appreciate such a fact.
So some would say, so what? Why is that a big deal? Number one, it's an example of God's purpose in creating the celestial objects for signs and seasons. Number two, we're going to have to ask, is this just a coincidence? I mean, of all the various reasons why the Earth is so perfectly designed for us to live here, and why the sun is so stable, and all these other factors that you have to say are so unusual, yet another one to add to the list. I mean, how many coincidences are we going to invoke in order to deny that there's a creator involved? The eclipses are not a necessary thing. They've been useful through history. Among other things, the moon going to the opposite side of the Earth from the sun was one of the reasons that early astronomers understood that the Earth was round. This has been known for thousands of years, by the way, unlike some secular people who claim otherwise until recently. But one of the reasons they were able to figure that out is because the shape of the Earth's shadow as it goes across the moon during a lunar eclipse. So it's been useful in scientific discovery, but to my mind, it's just a sign of beauty.
Naturalism would say that everything we see came about by chance and random processes. But as you look into the details of the moon and its impact of life on the Earth, it's hard to deny the work of a creator.
Well, if we did not have the presence of the moon with the unique orbit and its unique mass, there would be no stability, and you would have, over time, the axis of the Earth tilting, wobbling everywhere, and you'd have devastating climate changes or seasonal changes. Most plants can, if they can survive in the tropics, would never make it in the higher latitudes or the Arctic or Antarctic. Conversely, Antarctic plants can't survive in the tropics, but for a good deal of the time, plants would have to cope with both of those, which is not really possible, I don't think, from a physical standpoint. So these effects of other planets will cause the tilt of the Earth to vary wildly without the moon. But with the moon, it's a stabilizing effect. And I think that's showing a design application. I think Eclipse is showing a design. And there are a lot of design aspects in the moon. It's not just a body that's orbiting on the Earth. It's actually doing something that's beneficial for mankind. And to me, that's an argument for design. It's not just a happenstance or a coincidence. It's something that's been designed into the system for us.
Even in an imperfect universe, we can still see how God has set up everything for our survival. We know that the moon is important to the Earth. It has a number of purposes of things that it does for us. It's a calendar system for us. It's a nightlight. It keeps the oceans healthy. I think this is all part of showing God's plan, how He's put it together for us. But the fact is, God's glory, I think it goes back to creation.
The world of our Creator has no mistakes or flaws. Yes, it's marred by sin's curse, but our solar system and universe were put into place like an intricate clock. Each part has a role in making things work, including our moon. It draws us to worship the Creator for His amazing design and say, "The heavens truly declare the glory of God."